What is the internal one? Everything is internal only. Aditya, what do you mean by internal? Mission cycle 2. It is just, see, you say jump 8,000. Let's recap. Okay. So, good evening, everybody. Namaste, Harsh. Sura, good evening. Rahul, Rohit, Asif, good evening. Deepak, Dhanpal, Ritik, Ruchita, good evening. To complete today. Tour instructions. Let's recap so that everybody will be happy. What is your doubt? If condition is true, 10 key states are required. Please explain the internal one. What is the internal one? Everything is internal only. Aditya, what do you mean by internal? Mission cycle 2. It is just, see, you say jump 8,000. So it is jump, it is 0, 0. So you have the instruction JMB 8000. For jump, opcode, then 0, 0, then 80. Okay. Say if it is jump on carry. So here it will do opcode fetch. This is the first mission cycle. Then here it will do memory read. This 0, 0 is read and copied into the Z register. Up to this same. By this time, computer will know whether carry flag is set or not, whether carry is there or not. If carry is there, it will continue with the next, and there, what it will do, it will copy that W with this one. This happens if carry equal to 1. Else, it will jump to the next instruction. Tell me, what is your doubt in this? Aditya. Good evening, Pupul and Shubham. Aditya, please comment fast. We need to move. It is independent operation. Carry checking is independent. Reading Z is different. Okay. It is actually carry is based on previous instruction. Carry is not because of this 0, 0. Carry is already present or not. It is based on the previous instruction. Carry may be 1 or carry may be 0. It will check that condition. Okay. This is independent of reading this number. This is done by bus. This is done by ALU logical circuit. Tell me. Okay, fine. Let's go. Okay. Good evening, Abhineet and Ganesh. Okay. So what are the leftover instructions? What is where? Deep? Complete it, please. What do you mean by where? What are the leftover instructions? Let us recollect the leftover instructions. What are the leftover instructions we are having is jump is done, call is done. So we have to discuss conditional call is left, return is there, conditional return is there. Okay. Next, RST instruction is there, then PCHL is there, then stack operations will come. Okay. Push, pop, XTHL, SPHL. Then IO instructions will come, that is in and out. Then machine control, that is enable interrupt, disable interrupt, SIM, RIM, NOP, HLD. That will finish your total instruction. That will finish your total instruction set. This is what we need to discuss. This is the only part left over. Okay. So now, what is your pupil doubt? He has written so much. Sir, in jump while in FU, W just copy into the address bus. Okay. Yes, that is given in the class. Same thing. Yes, correct. Pupil. Pupil is not giving any doubt. Pupil is giving statement. Yes, it is true. Any lag is there? No lag is possible, as per my knowledge. Ask as many doubts as possible. No problem. Yes, you are asking doubts or you are saying the statements. What you said is correct, Pupul. What is the doubt in it? If you just remove the question mark, it is enough. Okay. So shall we move? Shall we finish this hopefully today? If you're done with that, we do some programming. Then we discuss interfacing. Then your course is done. Okay. So let's see this part. Let's see this part. Conditional call. Okay. So conditional call. Yesterday, if you remember, I discussed normal call. Okay. Yes. Temp is a register separate. WZ is separate. Please see at least architecture of 8085. That is the first lecture or second lecture. But WZ are also called as temporary because we are using as purpose of temporary. But there is a separate register with name temp. So conditional call. So here you have condition is satisfied, it will call, otherwise not call. Okay. So please see here. Call on carry, call on no carry, call on zero, call on no zero, call if parity even, call if parity on, call if positive, call if negative. This is if carry equal to 1. This is if carry equal to 0. If zero flag equal to 1. And this is for zero flag equal to 0. This is parity equal to 1. This is parity equal to 0. This is for sign equal to 0. This is for sign equal to 1. Minus means sign is 1. So this is conditional call instructions. Okay, say for example, if you say CC 16-bit address, if carry flag equal to 1, then okay, call 16-bit address, which is what we discussed last lecture. Okay, so here condition is to be checked. It need to check the condition. So for that, how much time is required or how much memory is required? Let us see. First point, 16-bit. Okay, call. So 3-byte instruction. Very good, Alcha. It is a 3-byte instruction. Everybody clear? Call. It is CP. Call if it is positive. M means negative, minus. Yesterday class I have given that. So 3-byte instruction. Next. Yesterday I have given definitions for jump. Now that's why I'm not writing here. So second, how many machine cycles are required? How many machine cycles are required? Please listen. It is, yes, yesterday we have discussed it, 5 machine cycles, but here condition is checked and condition is to be checked. So here, if condition is true, 5 machine cycles. Otherwise, 2 machine cycles. Okay, if condition is true, 5 machine cycles, condition is false. Why I am writing plus here? Just wait, or 2 machine cycles, like your jump only. Okay, so here what I have given yesterday already, opcode fetch plus 2 memory read plus 2 memory write. This is one method, or what I told, opcode fetch plus memory read, which will take 6 t states plus 3 t states. So next, it will be 18 t states, or what is the opcode fetch is 6. Yesterday we have discussed that. Okay, you remember or not? Then what is the addressing mode? It is immediate and also register indirect, because you are using stack. That also I told yesterday. Immediate and also register indirect. Okay, no flags affected because it is not a arithmetic and logical operation. Good evening, Lucky. Okay, done. Okay, I think I made a slide for this. Wait. OF is 1, MR is 1. Total how many? 2 or 3? What happened, Ritik? Tell me. OF is 1. Don't calculate O as 1, F as 1. Okay, OF is 1, MR is 1. Total 2. Where is my pro? Okay. I'm just checking for the slide so that you will understand betterly. Okay. Just wait, all your doubts will get clear. That's why I'm loading this. Yes. See here, this is what happens. Okay. Call if condition is true. Okay. It is not jump, it is call. Okay. So first 4 t state same, fifth t statement and sixth t statement. What it happens? SP will be decremented, but please listen, actually internally what happens is this will happen only when the condition is true. Otherwise you should not disturb the stack pointer. You should not disturb the stack pointer. That's why In the machine cycle 2, please listen here. Actually, this time will be counted here, but actually the computer may do this here. Okay. Why? Because it should not disturb the stack pointer. It should not disturb the stack pointer if your condition is not true, because you are not writing into that. Or it should correct it also at least. So now see here, this is the condition. Now address bus is copied. In the second machine cycle, it will understand whether the condition is true or not. If it is true, go to the third machine cycle, fourth machine cycle, fifth machine cycle also. Else what it will do? Program counter will be incremented by 1. Already it is incremented by 1. Here it is incremented by 1. So total how many increments happens? 1, 2, 3. So if yes, condition fail, PC is going to PC plus 3. If condition is failed, the PC will go to PC plus 3. Is it clear what I am saying? Right. Very good. So you see this. Condition is true. Please listen. Condition is true. 18. It is failed. That is false. 9. True 18. False 90 states. Next. Similarly, let's go to the next one. That is return instruction. Okay. What is that return? Unconditional return. Yesterday I told whenever return occurs, the computer will be copying the top 2 locations of the stack. If true, PC will not be loaded. I told yesterday, please remember that. WZ will be loaded with this address. In the next machine cycle, first 2 states may PC is copied with WZ plus 1. Also, please revise previous class before coming to this class. Yesterday I told it or not? Please tell me yesterday. You remember or not? Call instruction may, if it is true, or jump instruction, I told it already. When it is true, after completion, WZ will copy to address bus. In the second T state, WZ plus 1 is copied to PC. Okay. Now unconditional return. Unconditional return. What is the unconditional return instruction? RET. If I say RET, what it will do? First it will do opcode fetch, then stack pointer will be incremented by 1. Sorry, not into. I'm sorry, wait. Then whatever what we call program counter low is copied with, originally what it will do, I will show. Z is copied with contents of stack pointer. Then what you do, SP will be incremented by 1. Then third machine cycle made W is copied with contents of SP. Okay. And here SP will be incremented by 1. This is called SP incremented by how much? 2. SP incremented by 2. Now listen carefully. Okay, this is opcode fetch Z W. After this, listen here. It is FEO. That is first of next cycle. First of next instruction. Okay, Aditya, your doubt of previous also will get cleared here. Please see. Of fetch execution overlap may what happens? Your address bus is copied with WZ. Okay, address bus is copied with WZ in the T1 state. In the T2 state, PC is now WZ plus 1. So what the computer is doing, whenever I say return, the computer is returning back to top 2 locations of the stack. So what is the meaning of return? Return to top 2 locations of stack. Okay, generally it is internally happening. If something is asked, you can say PC is loaded with this. Blindly, one way is to say PC is loaded with the top 2 locations of the stack and go it. But PC is involved in this job. PC cannot be changed while reading this. Okay, this is memory read now. You need memory read. For memory read, your PC is the giving to address first. So PC cannot be dynamically changed. It should be changed after its job is done. So how many machine cycles here? 3. Okay. So it is 1 byte instruction, just written only. No address is to be given. Address is by default top 2 locations of the stack. 1 byte instruction. How many machine cycles? 3 machine cycles. Opcode fetch and 2 memory read. So 4t plus 3t plus 3t, that is 7t plus 3t. What is the answer? Do you have any doubt now? Register indirect address. RI means register indirect addressing mode. No flags affected. You may have the doubt, sir, here why 40, why not 60? Because while writing into the stack, you need to decrement first and write it. But while reading, first you read, then increment. This is called post increment. Okay, I will give you one point. Please listen. In 8085, stack push is pre-decremented operation. What is the meaning of pre-decrement? First you decrement and write. First we decrement and then write. This is one method. Next, pop is post increment operation. What is the meaning of post increment? First read, then increment. Very good, Sonali. Okay. Why this, sir? Why push is like that, pop is like that? Otherwise, it will not work properly. I will show you. See here. I will show you. Listen, please, carefully. For understanding easily, I am taking number 1, 2, 3, 4. Is it okay? I am taking 1, 2, 3, 4. Say, this is how push happens. This is how push happens. Say it is at 6. Okay. Stack pointer is here. Whenever I say push, what happens is, say I said push B and push C also, push D. Okay, forget about, I will explain push next, just for continuity I am saying. Okay, so when you say push, the computer first decrement and write it, then decrement and write it, again decrement, first decrement, write it, first decrement, write it. This is push. So if you say pop, okay, so when you say pop is nothing but the name used for reading. Okay, so your stack pointer is already pointing to the location. Stack pointer is already pointing to a filled location. Here some random is there, don't worry about it. So if I first increment and read, then I will read D. So first what I need to do? Read. Then you make 2 to 3. Then read. Then make it 4. First read it, then increase. First read it, then increase. Okay, so it should be like this: first decrement, and if you, there can be reverse also. That is, first write it and decrement. In that case, first you should write decrement, write decrement, write decrement. If you use that syntax, in that case, what to do? First we should increment and read it. Okay, but 8085 is not following that. 8085, what it is following? First it decrements and write. First it decrement and write. First it decrement and write. While reading, what to do? First you read it and increment. First you read it and increment. First you read it and increment. Otherwise, you don't get the data properly. You understand or not? Please tell me. Good. Okay. Hussein, please see, while pushing, it is the stack pointer is already pointing to some location. Some data is already there in that. Okay. When you want to write the data, what you do is first you decrement. First, you decrement this stack pointer, then write it into the stack. Again, decrement it, then write it into the stack. Okay. So like that, we first decrement and write. First we decrement and write it. Then this is where stack pointer is waiting. Now while reading, first you should read this number and increment it. Read this number and increment it. That's why what I told in 8085, push is pre-decremented. First decrement karke we will be doing this write operation. In the pop is post-incremented. First read, then increment. Okay. Indirectly, you are able to understand push and pop operations also using this return instruction and call instruction. Okay, because of that, you don't need here, because you are doing this not first, so it does not require extra time in the opcode. It does not require extra time in the opcode. So to avoid that, here you read only 4 T states. How many T states are enough for opcode fetch? Only 2. Yes, that is the case, Asif. We should follow one syntax. It can be reverse also, no problem, but one syntax should be followed. Otherwise, it is of no meaning. This is what followed in 8085. Okay, shall we move? Now, is it clear? Opcode fetch is only 40 states. Reason you understand? Good. Very good. Now, let's move. Conditional return. So that is return on carry, same story. No carry, 0, no 0, parity, odd, even, positive, negative. So all these are 8 different conditions are there in that. So I need not explain. I hope you understand. Yes or no? Very good. Very good. Very good. So now let us see how many T states each one is requiring. I think I have that slide. Let me. Yes, Aditya. Very good. So here, this is what happens in the return condition is true. So opcode which here requires 2 extra T states. Why extra T states are required, sir? To check the condition priorly before doing the second machine cycle. Before doing the second machine cycle itself, I think I uploaded the previous one. Okay, wait. Okay, see, this is the thing happens. Opcode which happens here 2 extra t states are required. Why extra t states are? If condition is true, okay, condition is true, then go to machine cycle. Else, don't go there. Else, it will not go there. Okay, so please understand here what is that? It will not go there. Why it will not go? What is the machine cycle 2 here? What is the machine cycle 2 here? That is reading the stack. Okay, reading the stack. That is read the stack and all those things. Okay, you cannot do this if condition not true. Why, sir? You may have the doubt, sir. Earlier we did not, sir. This I didn't check it directly. I came here while parallelly checking it. I read some data. Earlier you have done that. Yes or no? Tell me. Earlier you have done that. Okay, but here you cannot do it. Here you cannot do it. Why? Here you cannot do it because actually I think I made some mistake here. Where is that? I'm sorry here. Actually, it is not memory read. It is a stack read. Na? I'm sorry. I mean, reading from stack, PC can be directly. 1 minute, 1 minute. I'm sorry here. While doing the return, PC can be directly loaded because these two instructions may. Who is taking care of the address bus? Stack is taking care of address bus. You don't need WZ here. You don't need WZ here because who is taking care of this return operation? Stack is taking care. So PC can be directly loaded here. So PC can be directly loaded here. Okay. So now come here. I'm sorry for that. Now see here. So here PC is directly getting loaded. 1 point. Second point is in this second machine cycle, stack is changing to +1. So these two operations cannot be done if the condition is not true. If the condition is not true, you should not disturb this. So this operation cannot be done without checking the condition. Your PC contents are changing. Your SP is also modifying. So in this case, first check it, then only do it. But for jump, that is not the case. Why? You are using WZ registers only. No stack is involved. There you can do it. It is of no problem for us. No, it is incremented 2 times. You see here once, here once. Who is that? Vasista. What is your doubt, Anuj? Please tell me. Machine cycle 2 is done only if condition is true. If condition is not true, okay, please listen. If condition, computer will check during the T5 and T6 states whether your condition like carry flag is 1 or not, 0 is 1 or not. These conditions are there, na? Computer will check it at this time, T5 and T6. At this time, it will check it, okay? And while after checking, it will come to this machine cycle. But earlier, I have loaded, I think, this one. Earlier, whether it without checking, it enters into machine cycle 2. Okay. Why? Because here you are loading the data into what? Temporary register. Temporary register can be modified, no problem for us. But here, you are loading the data into whom? Program counter, and SP also incremented in this machine cycle. So this machine cycle is modifying SP and PC. It should be done only when required. If it is not required, you should not change it. But here, this machine cycle second is not modifying any SP or PC. PC is incremented. That is required anyway here. To jump to the next instruction, even if the condition fails, it increment one more time. But SP and PC contents are not modified. I mean, in the sense, data is not loaded. You understand this or not? Please see the difference here. PC incremented is required only here. PC should be incremented 2 times so that even condition fails also, no problem. Okay, and you are writing the data into Z only. So even you do this machine cycle, condition failed, no problem for us. But here, if you do this job, but condition failed, then I need to modify SP again. I need to modify the PC again. PC contents are modified. So you should be taking care here. That's why first they will check it here and enter into this. So for that, please listen here. You can see here. It contains 1 byte instruction only. Three machine cycles, or just wait, 1 machine cycle. Okay, then it can be 60 plus 3t plus 3t. It is 60. That is 12t or 60. What are they? Opcode fetch plus 2 memory read, or only opcode fetch. What is the addressing mode? Register indirect. No flags affected. Yes, correct, Sonali. Don't generalize the things, Avicca. It depends on the particular instruction. Okay. Every time you need not load into PC, but here you are moving to PC. That's why we used PC. Yes, in the previous case, please listen. During call operation, please see. This is where call operation is performed. If condition is not true, computer will jump to here. So PC is to be incremented. Condition is true, computer may jump to this location. So here PC can be incremented, not an issue, no problem. Yes, Sonali, what you said is 100% correct. So shall we move further? Why silence here? Tell me. Tell me, please. Shall we move further or not? Yes, yes, yes. So conditional instruction call is yes. Let's move further. Okay. So next one is the next instruction. What is that? Where is that slides? First slide. So be happy. We have done this part, this part, this part. 3 parts are over. Okay. So we are moving to this one now. What is that? Where is the slides? Yeah. RSTN. This is what we call software interrupt. Very soft. Okay. RST means restart. Restart in the sense go to. Yes, I forget to start spelling. From vector address n into 8. Yes, ask Aditya. Here n can be 0 to 7. If I say RST6, what is the vector address? Computer will move is a 6 into 8. That is the location it will go. 6 8s, how much? 48 in the decimal, or it is 0030 in the hexadecimal. It depends on instruction. Okay, every time WZ is only used. Okay, SP is used only when stack pointer is involved. Aditya, don't remember the things blindly. You should see the instruction and identify that. Okay. If it is a stack pointer operation, you need to move the stack pointer, then SP is used. Otherwise, to store temporary data, we use WZ only, except this case where PC is directly loaded. Remaining all cases, we use WZ only. Okay, so like that, RSTN. Okay, you can have 8 variations in this: RST0 to RST1 and so on, RST7. Okay, 8 variations are there in this instruction. So now let us see one more thing, that is your RSTN. What is how many byte instruction? It is only 1 byte instruction. Next. Okay, it is a 1 byte instruction. How many machine cycles are involved here? Tell me. 1, 2, 3, correct. See here, PC loaded into stack and jump to n into 8. This is like 1 byte call instruction. RSTN is also called as 1 byte call instruction. So we are going to interrupt service. Before that, what it will do? Program counter will be loaded into the stack. Program counter will be loaded into the stack. Same as call instruction, but here address is fixed. In call instruction, you give address, but here address is by default vectored. It is fixed. It will go to n into 8 location directly. So it is a, why I write 1 byte? Yeah, it is 1 byte. Why 3 byte here, Aditya? Address you are not giving. Yes, it is 3 machine cycles, opcode fetch plus memory write plus memory write. Program counter will be loaded. Very good, very good, very good. Here opcode fetch requires again 60 states. In your total 8085, around 6 or 8 instructions will take 60 states. Okay, just remember them, not an issue. 3T, 3T, which is 12T. Why 60 states, sir? T5, T6, okay, used to calculate vector address. To calculate the vector address, which is n into 8, this calculation is to be done now whenever this instruction comes. First 40 states, computer understand this is the instruction it should perform. Then it will calculate and move there, because next it should load with new address. Then you cannot over, what we call FEO. You cannot overlap the fetch and execution of next. Next address is to be calculated. Then only you can proceed. You cannot overlap these two. Okay. Yes, yes, yes. That is taking place. Next. What else? What is this addressing mode? It is you are using the pointer. It is a register indirect addressing mode. And what is that? No flags affected. Why implied? You are using the register indirect addressing. Stack is being used now. Okay, Aditya. It will just read the opcode. Computer will understand based on opcode only. Okay, in the opcode, you will be having 3 bits which are dedicated for 0000 to 111. Okay, when that is 000, it understands RST0. When it is 111, it understands as RST7 also. I think I have made that. I will send you once, 1 minute. Where is that? Yeah, I will show you that table also. Don't worry. Okay, guys. Now see, you can visualize the T5, T6 states. Mein what happens? Address is calculated. Okay, your favorite. Who will store this address? People. Okay, WZ will store that address. Okay, it will not left in air. Then in the second and third machine cycle, stack pointer may what happens? The story is same. SP is decremented by one here, SP is decremented by one another, and this what we call program counter high and low will be copied. Then in the next machine cycle, okay, of the next instruction, this is FU. WZ will be copied and WZ plus 1 will be copied into the PC. That's all. Okay, is it clear? Fundamentally, everything is clear. So what I want to say here is SP will be decremented by 1. Anything else I left? Yeah, vector table I need to load. Okay. Earlier I have done one question also. Okay, now I will do the same question again. Now let me check how many of you able to answer it correctly. Interrupt vector table, where it is? Thinking, yes. Hmm. Okay, you can see the RSTN code, RST 0, 1, 2, 3, 4, 5, 6, 7, 8. So both the software and hardware interrupts now you can see. Okay, this bubbled ones are software interrupts. Okay, and these green ones are hardware interrupts. Hardware comes from external. Okay, what is the meaning of RST 4.5? Is nothing but a trap. Ah, okay, this is the interrupt. We call interrupt vector table. It is interrupt vector table of 8085, which will give you vector address of particular tables. Yeah, because it is non-vector. Good, that's it. So anyone having any doubt? Any kind of doubts, ask me now. Now answer this question. This question now you people, earlier we have done this question already, but still, now you will get more clarity on this question. That is the reason I took this question again. So just give a reading. I will do the poll again. I hope you remember the answer, but no problem. Are you ready? Shall we start the poll? Yes or no? Very good. Yes. Okay. Wait. Not a trap, not a trap. Okay, I'm sorry. Let's start the poll. Okay, very good. Very nice. No screenshot, it became less than 100. Yes, we have done. Good. So see here, I told already earlier also unconditional jump, but now you visualize this. So see here, between this and this, what is the gap is 8 bytes. So there, what you can write? We should write jump instruction because the gap is only 8 byte between this to this. You cannot write the whole program of ISR here. Interrupt service subroutine or interrupt service routine, whatever maybe, you cannot write it. So what to do is, in that case, you should write jump instruction only. It is unconditional jump. No condition is required. Just when computer comes here, that is when ISR is executed, it comes here, jump there. Okay, here condition need not be checked. And another case is what? You need not have call also. Okay, because already when we come to RST kind of instructions, whenever interrupt comes, already program counter is loaded into stack. Already loaded into stack. Why to have call? Simple jump is enough. You can have jump and return also in that case. Is it clear? Why not call? Why only jump? Call requires more. I mean, call will store again this what we call time will be taken more. Okay, because it need to store the program counter, all those things. That is not required in the jump. Okay, why jump is preferred here? Because interrupt itself already stores program counter and count. Now it is clear to everybody. In the basics we have did this, but now it will be more clear for you. In this 8085, the gap is 8 byte, not 85. It is some microcontroller. For that, the gap is 8 and 10. What is the gap between them? Hexadecimal. That is not your job, Asif. If it is maskable interrupt, you don't get into the ISS address itself. Okay. If you enter that address, you should do the job. He has not specified that now, we can leave that. So because the interrupt service routine is 32 byte, but you have the space of only 8 bytes, you cannot do. Here also, gap is how much? 8 byte. And here only 4 byte. So what you write? We write jump to ISR. Right. Next instruction. Your return is completed. The next one is PCHL. It is a simple instruction. Program counter is to be copied with HL. Nothing more than that. Simple instruction. Program counter is loaded with contents of HL register pair. Program counter will be loaded with the contents of HL register pair. For that, you require how much time? Just only one machine cycle is required. Just to copy the register contents. That's all. I'm sorry, where is that? Import PDF. Right. Right. This is your, where is that? Sorry. Yeah. Good. So this requires also extra 2 T states to copy this L and H values in the program counter. L and H values in the program counter. Okay, so PCHL, SPHL, RSTN. Okay, I will give you those numbers now. Okay, just after push instruction, I will discuss that. So it is a 1 byte instruction. It is possible. I don't know why he has not taken. According to me, it is possible. Why can't we take directly address bus my HL and the next HL plus 1 into PC? I don't know the reason for that, but he has not taken that. Okay. It is like 1 minute. It is like a 1 byte jump. Previous one is 1 byte call na RSTN. RSTN is like a call instruction. Here it is like a jump instruction. Single byte directly. What is the meaning is already HL will have some address. That address is copied to PC and it will jump. It is a simple 1 byte instruction. 1 byte instruction. Okay. And it is a 1 byte jump instruction. HL is copied with PC. PC will go to the new location. It is the only instruction available where register is copied to the program counter directly. So HL can be loaded with your require and load this here. So only one machine cycle. How many? 60 states. So T5, T6 are required for what operation? To copy PC with HL. Okay. Then opcode fetch only. What is that? Addressing mode. Register addressing. PC is copied to HL. Very good. No flags affected. So finally, we have finished the branch group of instructions. We have finished the branching group of instructions. Okay. So let's finish the next part. Stack. One minute here. I want to add two more instructions. I forgot. I have added. So this is done. This is done. It gives some happiness when you complete the job and strike it off. Okay. So when you study for your exam also, networks is there, basics like that. You make one paper complete, then strike it. Complete and strike it. So it gives some energy to you. Okay. I used to strike paper after reading the newspaper. Earlier, when I try to understand general studies, because I hate that. So yes, that is also correct, Shivam. Yes, in childhood sometimes we do as if. So stack operations. Stack operations you have push and pop. Stack operations may you are having push and pop. Okay. So listen here. First we are doing push operation. Push register pair, that is it can be BC, DE, HL. Okay. I do that, Avichan. So while studying for my gate, I did that. So people afraid of sitting just beside me when I'm studying. Okay. So not in college, in home when I study in friends' room like that. Suddenly we shout after getting the answer, then people will see you like mad. Okay. Right. So see here in push you have four variation. Push register pair, push B, C, D, E, H, L, or push PSW. What is the meaning of PSW? Program status word. Program status word, which is nothing but accumulator plus flag register. So this instruction can be used to save your accumulator and flag before doing some job. Then after completion of that job, you can retrieve the back with the help of pop instruction. Okay. So if you say push RP, what are the conditions takes place? Opcode fetch will be taken place. Then SP will be decremented by SP minus 1. It requires two T states, T5 and T6. What is that I told? Pre decrement. Then what I told. Hmm. First opcode fetch is decremented, stack is decremented, then what happens is the first push may what happens is the particular register pair is copied into the contents of the stack. First we copy RPH, then again SP will be decremented by 1. Then third case, again your SP will be copied with RPL. Good. So now this is a memory write operation. This is memory write operation. Here, overall, after this job, your stack pointer is decremented by how many times? 2. Stack pointer is decremented by 2 times. Okay, stack pointer is decremented by 2 times. Now, how many bytes? It is 1 byte. See, please understand. First high is copied, then low is copied. First register pair high will be copied, then register pair low will be copied. But while returning, reverse will come. While returning, first low will come out, then high will come out. Okay. And another way is to remember, if it is a PSW, first accumulator will be copied, then flag register will be copied. Okay. So stack after push operation, this is important. After push operation, stack pointer will be decremented by 1. SP is decremented by 1. After push operation, stack pointer is decremented by, not 1, I'm sorry. 1, total 2 times. 2 times stack pointer will be decremented. Hopefully, we need to complete this instruction set today so that tomorrow we don't have burden, we can do more questions. And I forgot today is a doubt clearing session at all. Yeah, if required, I will take today little more time. Okay, is it okay for you? Good, because we have today's Thursday only 2 days, so we will complete it. SRAM will do Aditya last day. So it is your push instruction is 1 byte. Next, 1 machine cycle. Sorry, how many machine cycles? 3 machine cycles. Opcode fetch plus memory read. Sorry, not memory read. What is that? Memory write plus memory write. So it is 6T plus 3T plus 3T, which is 12T. Why 60? I told that. Okay, because this is the where you require extra time. Next what? What is the addressing mode? Register indirect addressing mode. Next, not register. You are using stack, memory pointer. No flags affected. And SP will be decremented by SP minus 2. This is the, you should remember this thing. So this is about your push. Already I told earlier about push instruction. So same thing happens. First pre-decremented operation. First decrement and write it. Then after push we should discuss pop. Pop operation. So pop register pair. Okay, it can be BC, DE, HL, or you can have pop PSW. What is PSW? Accumulator plus flag register. So now, if you say here, why to write this way? So pop is just what happens in the pop instruction. First opcode fetch, then first read, then increment. That is, first read into the register pair low the contents of stack pointer. Then you increment your stack pointer by 1. Then register pair high is copied with Again stack pointer. Your job is done, but you should not leave it. You should increment by 1 so that it is ready for with next location. Otherwise, this location will be read by another fellow. So this is a memory read. So here SP increment by 1, not 1, right? 2, right? Very good, very good. So how many? It is 1 byte instruction. So how many machine cycles? 3 machine cycles. Opcode fetch plus 2 memory read. Here opcode fetch is only 4 T states. Why 4 T states? Because here stack is incremented after, not before. Stack is there, but it is incremented after, not before. That is pre-decremented. It is a post-incremented. So it can be done while doing the memory read operation. Opcode fetch you need not worry about that. Then, okay. So here your SP will take care. Your address bus will be copied with what? A15 to A0 is copied with SP only. Not your PC. PC is not having any job in this case. PC is job free. Okay. Here also address bus is copied with stack pointer. Yes. Register indirect mode. No flags affected. Right. Except pop PSW. PC is only here. If it is PC, PC plus 1, it will stop here itself. PC will not vary more than 1. That is, after this instruction, PC will continue with the next. Okay. And SP is incremented by 2. You understand, pop PSW may flag can be changed. When you say pop PSW, your particular program status word, that is accumulator and flag, can be loaded with your required contents of SP. Whatever there in the SP will load into flag. So to load the flag, you can use this instruction pop PSW. You write something required in the stack and load it here. Or whatever you have stored earlier can be retrieved also. Okay, let's go next. Why all are silent? You want to make some noise? So this is about your push and pop instructions. In deep dive into processor. So this is for push now. Why this is like this? Okay, for push, this is what happens. You see, address bus is copied with a stack pointer, not program counter. Here, PC not involved. Okay, next. Similarly for pop also we can do. Now the next one is PCHL. Okay, PCHL. So HL is copied to PC. No, I will say thanks to you because you said my word. Okay. PC is copied with the HL register where PC HL is copied with PC. Okay. HL is copied. Then I should not thank her. I forgot that she only deviated. Program counter is copied with HL. This is done. See, I am also deviated because of you people. I want to explain SPHL, but I am writing PCHL. Yes, we need to give her credit. SPHL stack pointer is copied with the HL register pair. HL register pair. Here also, it is just 1 byte instruction, 1 machine cycle, opcode fetch, and here also 60 states. Why 60 states, sir? T5, T6 में क्या करेगा? SP will be copied here itself with HL. Okay, this is 1, this is 2, this is 3. Then please listen. Register addressing mode and no flag affected. So stack का एक और हो गया. So let's tick mark that to get some energy. Push हो गया, pop हो गया, SPHL हो गया. Yes, I hope we can make it today. Yes or no? Can we complete today? Hopefully. Good. So the next one we are going to do is XTHL. So examiner at least he should give 4 or 5 marks for this subject. What do you say? And this is not fair. Then everybody comes to this subject, they will show the interest and they will learn in the proper way. Okay. But see, for digital we spend around 80 hours. Here we are spending only 22 hours only. Okay. But more theory and more things we know it, but it is logical good subject it should they should give more weightage. Earlier, that is the reason, because earlier gate paper is 150 marks. You know it or not? Earlier days gate paper is 150 marks up to 2008. That is the best thing. At that time, each subject used to get around 15 marks. In that time, 4 to 6 marks comes from microprocessor only. Descriptive is before that. Descriptive is before 2000. Okay. So, listen. So 150 marks in that time, 4 to 6 marks only from microprocessor they used to get. This from digital, in that they used to give. That is where at that time what happens, every subject may selectively, if students prepare also, they will know 15 marks is there in a subject. If you leave one topic, no problem. 2 marks may go or 4 marks may go. But now each subject is having 6 to 8 to 10 depending on examiner mode. You cannot guess the paper. You cannot leave a topic also in this case. From where they give it purely depends on examiner. Who said Asif? Every year they are giving one question. Maybe in 1 or 2 sets they are not giving, but every set, at least in one set, one question compulsory they are giving. In any set they will give. 2020 they have given one question. 19 I have not seen. For EC definitely they are giving. Okay, in any one of the set. Okay, 14 to 19 in double G. I'm not sure with all the sets, but 2020 they have given, right? So let's move. It's not principal or principal. 2020 analog only 2 marks. Okay, right. Now see here, HTML, sorry, XTHL. It is having HTML, no, HTXL. Right. What is the meaning of XTML? It is a code word. Exchange top of the stack with HL register pair. Exchange top two locations of stack with HL register pair. Exchange top two locations of the stack with whom HL register pair. How it will do? See here. First it will do opcode fetch. Then, okay, then whatever present in the stack, that is copied into some WZ register. Then again, it will increment the stack. So for example, for Z is copied with, I will explain, contents of SP. Then SP will be incremented by 1. Then W will be copied with the content of SP. Now, the content of SP will be copied with HL register pair. And SP will be decremented by 1. Next, contents of stack pointer is copied into L register pair. That's all. Simple path. Okay. You understand here the process. First, suppose you assume 2000 location is there. You have 0, 0. Here 1, 1 is there. You have HL register pair with 2, 2, 3, 3. So first pointer is here na. This will, okay, or 1 triple F. 1 minute please. This is 2000, 2001. Okay. So here your pointer is there. Okay, this will be copied into Z register. This will be copied to W register. So increment 1, here it will come. Now H will be copied here, and W may whatever you stored, that will come here. Swapping the data only. Okay, I will show you that. Let's take one example, it will clear betterly. Say your stack pointer is here at 2000 location. Okay, here you have 22, 23, whatever, 43. Is it okay? So what we do is, in the second machine cycle, first you copy this to the Z. Z will become 23. And this you copy to W, 43 it will become. Already HL is having, for example, tell me any number here. HL ka number. Don't say same number. 5432. 43? No, I don't like your numbers. Give me some good simple number. 33, 44. It looks smart. Yes, 33, 43, 44 I took. Okay. Now see here. This is a second machine cycle May it will happen. Third May it will happen. Okay. So now see here. Now see here what happens. This H will be copied into. So here SP will be incremented by 1. First this stays, second this stays. 43 is copied now. Now this H will be copied here. That is 43 replaced by 33. Then again SP decremented. First increment kiya, then decrement kiya. Then this is copied with L. Meanwhile, we give this to HL. HL will become what? 43, 23. So these things will also happen, and that thing will also happen. Please listen here. We need to read the data 2 times. We need to write the data 2 times. So you have the operation of memory read, memory write, memory write, because you are writing and also reading. Is it okay? Okay. So listen here. Let me show you that. That is XTHL, right? Let me check where it is. Okay. So see here. First T state में XTHL will be 1. That is the opcode is decoded. Then SP will be incremented 1. Z is copied. Then here W is copied. W is copied. Then SP decremented by 1. Okay, then what happens? Your H register contents are copied into your address bus. Okay, that is SP. Contents will be copied with H. Now H is free. Now copy H with the W value which you want. Parallelly it happens. Similarly, L is free now. L will be copied with this one. Okay. So you need not worry much about these details, but understand here how many machine cycles? 5 machine cycles are required. So one time SP is incremented, one time SP is decremented. Finally, SP will be remains unchanged only. So see here, it is only 1 byte instruction. एक ही byte. How many machine cycles? 5 machine cycles. Opcode fetch plus 2 memory read plus 2 memory write. Then 4T plus 3T plus 3T plus 3T and 3T. Total how much? 16T. You see here, we are not doing any pre-decrementation. First you are reading, then writing. Okay. There is another 16 T states. Na? I think what is that? During data transfer we have discussed it. LDAX, LDAX, LHLD, SHLD. Okay. Yes, Aditya. Now, what is the addressing mode? It is register indirect whenever stack is involved and no flags affected. And stack pointer is unchanged. Because it is a stack operation, I am giving this also. So that is about your exchange top of the stack with the HL register pair. Finally, we are able to finish this part of stack and all these things. Oh yeah. So branching is over, stack is over. We were left over with the small instructions only. We left over with the small instructions only, not much deal. So we are moving forward. So let's see the next one. So let us discuss 1 minute. One important problem is there. We can discuss that so that it will be clear here itself. Let me download from the mail. Where is that? 1 minute. Yes. Right. Why it is not downloading? Yeah. Read this question. Read that. I will start the poll. Pola. So let's start the pola. So okay, ready. Okay, see, good. 90% gave right answer. I am very happy. So push requires more time. Let me zoom. In 8085, push operation requires more clock cycles. Okay, more T states than pop operation. Which of the following is the reason for it? So tell me, if you don't know the internal operations, you cannot answer this. So for pop, the data transceivers remain same direction and instruction fetch. It may be correct. Okay. Transceiver means you will be having some kind of two buffers connected like this. Tri-stated. Okay. It will be outside or inside. This is what we call transceiver. Okay. The same for pop, it is same. Pop means reading, same as opcode fetch. This is correct only, but this is not the reason. Okay. Memory write are slower than memory read. There is no meaning for this. But stack pointer needs to be not determined. Actually, it is decremented. I don't want to modify so that you will be knowing that is the answer. That's why I haven't modified. So pre-decremented before writing registers in a push, whereas pop operation uses the address already present. This is the reason. Post increment and pre-decrement is the reason for a stack requiring more time. Okay. Anyway, 90% gave right answer means you can say okay only. So let's move. Why this is loaded here? Starting itself. Oh, no. Good. This is there in your DPP actually. Right. Then when we complete the instructions here, we will do few more after completion of the instruction. In and out instructions. These are used to transfer data from I/O devices from or to I/O devices. Shall we do one thing? We have half an hour more now, so we finish these two instructions. Anyway, we are running on time. I mean, we are doing good. So we do one thing. These things we discuss tomorrow. Now after this we do problems. Even I also feel boring to discuss that much theory. Okay. Tomorrow we discuss this, then we see loop programs, etc. That will be good thing compared to this one. Okay. So why to waste total time on theory only? SRAM last day karega. Adicha, don't worry about your SRAM. It is there with you. Okay. So we do first this IO. Okay, your syllabus is going to complete day after tomorrow, no doubt in it. So this is completed. Then what we discuss is programming part. We discuss. We'll do few good programs. Then interfacing part. Okay, memory is not needed for double E. Memory is needed for everyone here. Whether it is double E or mechanical or uneducated, educated, anyone need memory. I can't. So these are used to transfer the data from or to I/O devices. Okay. Otherwise, I'll write like this. Used for data transfer. Who asked that? Memory, that SRAM, DRAM not required for W people, it is only for EC. Okay. So these are used for data transfer between IO devices and accumulator. Here IO device address is 8-bit only. IO device address is 8-bit only. What is the address of the IO device? It is just 8-bit only. Okay, so let's see in and out instructions. Let's discuss in and out instructions. So let's write. Is it clear what is in and out instructions? These are used to when external devices, input output devices are connected to the computer, they can send the data using this instruction. They can give it to the accumulator or they can read from the accumulator. Accumulator may write it into the output device or computer can, IO device may write it into the accumulator. So for that first instruction is in 8-bit address. Generally they will come under data transfer group only. Okay. So in instruction, when I say this, here only one fellow can communicate. Who is that? Accumulator. The content of 8-bit address is directly copied into the accumulator. So see here. This is your memory. If I say, for example, in 80 hexadecimal, it is the number address. Okay, here address is only 8 bits. So I need to go there, opcode fetch. Then I should do memory read machine cycle. I should do memory read machine cycle. Okay. Then what to do? Then what to do is go to the address 80 of IO. That is, it may be input device or output device. Here you are reading from that. So it is an input device. From there, you should read it and give it to the accumulator. Here some number is there. It is giving some data to the computer. That will be copied here. Okay. Here whatever you are doing now, this is called IO read because you are reading from IO device. You understand input output device like your keyboard, your plotter, whatever may be. Your IO device is there externally. From that device, computer will read the data and give it to the accumulator. It may be some reading coming from some device, some sensor or temperature sensor, something is giving this data to his, is available here. That data, maybe some ADC is there. That data will be taken by the accumulator. We see that kind of programs. We can see that kind of programs like how to interface what we call temperature sensor to 8085. At least a few programs we do it. Is it okay now? So in this process, first one is it is a 2-byte instruction. Opcode will tell that computer, Amarendra, opcode will tell that the instruction is IO instruction. Accordingly, it will read the next. Computer knows the next byte is opcode or address or data, everything from first byte of instruction only. There opcode will decode it. Decoding may it will understand. So 2-byte instruction. How many machine cycles? 3 machine cycles. Very good. Opcode fetch, memory read, IO read. That is 3T. Sorry, why 3T? 4T, 3T, and 3T. So it is 10T states. Next. What is the addressing mode? Direct addressing. Directly you have given the address. No flags affected. You should get one doubt. You should get one doubt. I am waiting for that doubt. It is no flag because it is a data transfer group of instruction. Where is Ardham? ALU is involved. No ALU is involved. You are just reading now. It is a just arithmetic, data transfer group only. It doesn't matter. Data transfer group can be 0 or 1 or all ones, positive number, negative number. It doesn't make any sense. Computer will, ALU is not involved, flag is not affected. In that case, in this case also your flag should affect. Not FUO. Yes, Asif. 8-bit address is there now. How computer, it is having 16-bit address bus, how it will deal? How 16-bit address will be deal by your computer? Here it is 8-bit address. So who will take it, sir? Lower will take or higher will take? Both will fight with each other. Okay. So lower order to be given this address or higher to be given this address? Why lower? You like lower address? It is not lower, it is not higher, it is both. It is both. Please listen. Depends on processor. We are discussing 8085 only, not other processor. Okay, it is both. Why I am saying this both is important? Because when you connect IO device to the 8085, so when IO device to be connected to the higher order or lower order means both can be connected. For any bus you can connect it. Higher or lower, both will be copied with 80. So in this case, what happens? The address bus A15 to A0 will be copied with 80. You use either lower or higher in the interface. Hardware may you take the lower part or higher part, no problem. Okay, so let me show you that. Let me upload the things. Opcode fetch it is used. Opcode fetch is as it is now. Memory read is also as it is. Only during the last machine cycle I am saying. Let me show you. Please listen. Please listen. Why this is like this? Is it visible? You blink your eyes, it will be visible. Okay, somehow it is visible now. Yeah, Ruchita, just wait. See here, this is a opcode fetch. It is same. It is same. Please listen. Opcode fetch is same. Is it okay? Shall I upload again? Is it fine? Okay. So address bus is copied. All the story is same. Microprocessor understand it is input port. Opcode fetch mein total address bus is used. Please understand. Opcode fetch is as it is. Next, what you do? Memory read. In this case, also total address bus will be used because to read the data, to read the address, where this address is loaded. This is important. Who will take care of this? Always our friend is there for that. Who is that? WZ. Here you observe the variation in the internal of the processor is both W and Z. Okay, both WZ will copy the same number. That 80 is taken by both of them here. Okay, so now listen here. The last one. See here. Then your address bus top and also bottom both will be copied by W and Z. That is the same number 80 and 80. 80 is my example. Okay, so address bus top is copied with 80, bottom is also copied with 80. So during 8085 in and out instructions, who will get the this is one gate what we call IES mein question diya like this. In 8085 during in operation, okay, which part of address loaded with IO address? Okay, option A lower, higher, both. Why polar? I just explained. So this is given in one of the IES paper. What is the question answer is both. So generally people will explain you only what is in operation. What happens internally is required. Sometimes some questions are coming based on that. So is it clear now? Both will be loaded. Ruchita, now it is clear. IES, ESC, Engineering Service Exam. Okay. So exam, what we call the manufacturer has given the flexibility, use any bus because my bus is free, take it. Okay. To do that job, you need only one person. But I have two persons here, take both of them. Whoever you likes, use them. Okay. So that is how this processor is made. So let's move to the next. You can say similarly out also. There is another instruction. What we want to discuss now is out 8-bit address. Out 8-bit address. In is completed. Now out 8-bit address. That is accumulator contents will be copied into the 8-bit address. Reverse. Now, see, ambiguity is not there. You can use anything is not an ambiguity. Which one is to be used is an ambiguity. Okay. And here that is connected, hardware is connected by you and me only. That is your people only. So computer has not have anything in that case. You are only connecting to the IO device. Say for example, out 8-bit address. 8-bit may take some number. 47. Okay. As Harsh told, let me take 47. So accumulator will be copied with the contents of the location 47. So here out 47. We store this. You require memory read. Sorry. Opcode fetch, memory read. Then it will come to the location 47. There you have output device. Okay. You are displaying the result with the help of this instruction. 7 segment display is there, for example. Okay, so here I'm sorry, accumulator is copied into this 47. That is IOW, IO write. Okay, so it is 1 byte instruction, not 1 byte, 2 byte. 3 machine cycles, opcode fetch, memory read, IO write. 4T, 3T, 3T, 10T. Okay, what is that? Direct addressing mode. No flags affected. Actually, this will comes under data transfer group only, but for IO, not for memory. Okay, data transfer group for IO, you can see. So that is about your IO instruction. So we move little forward now. These two people are also completed. Let's strike like this. Okay, right. So now we left with only this. This we take tomorrow. Then today we discuss some problem. What is your problem, Aditya? Here 80 is your address. So during the third machine cycle, address bus high and low both will be copied with 80. That's all. You can use either higher order bus or lower order bus. Tell me what is your doubt in this. Who will decide it? Aditya, who is connecting it? You only. You take any one of them. What is the problem? It is address now, not data. If you are reading the data, computer will be confused from which location I need to read the data. It is not like that. It is given with address. Address bus mein whatever you connect here and here, same address only. Computer will go to the same location. From that it will copy it. Okay. But don't connect different devices in the higher order and lower order. That will trouble you. Okay. You should use either one of them. Don't here I connect one device or here I connect one device and I will play. No. So let's do some questions because it will be interesting. So I gave 70 questions for your practice. Today you can try. So let's do this question. Ready, guys? Write down the sequence of till halt instruction if the program begins from the location. Okay. Say here in this program, what you need to write is what is the original sequence taken by the computer. What is the original sequence happened by the computer in this program? Shall we do this? Yes or no? Comment. Okay. First, here XOR A with A. A is equal to 0, 0. LXI H comma 2000. HL will be copied with 2000. Program counter is copied with 2000. So from here, your CPU will jump to 2000. So this part is skipped. Now HL is copied with double F, double F. Shall we zoom a little? Okay. Increment H. Then HL will be becoming add 1 to double F, double F. What you get? 0, 0, 0, 0. Okay. Then jump if 0. Okay. Jump if 0 to where? 2100. Will it move to 2100? Yes or no? Yes. Why? Why yes? Actually, this will not affect any flag. You remember it or not? Increment H will not affect any flag. But luckily, the programmer has made this na here your 0 flag will be 1. Already this is 0, 1. It is a data transfer group that it here also not affected. Then we move to here not affected, here not affected. So this 0 flag will be taken here and move to 2100. 2100 mein kya? This one. So HL is copied with 1 double F double F. Even you commit a mistake, luckily you are getting the answer in this case. If I am the examiner, I don't keep this instruction. Okay. So then move A comma M. A is copied with the content of 1 double F. 1 double F mein kya data hai? See, 1 FFE mein ANI is there. 1 double F mein what is the data you are having? Tell me here. Then increment A. A will be 0, 1. Halt. Stop. So these are the instructions run by this. Here no flag is originally affected. Please understand that. It is because of this XOR A with A this is happening. Okay, why it is 0? Because accumulator is copied with the content of HL, that is 1 triple F. Thank you, Alcha. You are happy? So let's do the next question. Let's do the next question. So through questions you will remember the concepts happily. So the program given below is run on 8085 microprocessor. Determine the contents of PC, SP, BC, DE, HL after halt instruction. Okay. LOC means location, not that LOC. What happens, people? Tell me. 1 FFE may you have ANI opcode. This 00 will be in FF. Okay. Suppose here 2000 may Alexa H opcode will be there. This double F will be at 2001. Double F will be 2002. Location. Okay. So this is the location. I need to zoom up here. Right. So what is the contents you want? We'll do everything. What is there here? SP copied with 1000. HL copied with 2F37. Accumulator copied with 00. A copied with H. Why don't zoom? Any problem, Aditya? Increment H. Accumulator will become increment H. If you add 1 here, it will become 30. Then push H. So your stack pointer is having 1000 now. Push means, please listen, it is in 1000. Whenever I say push, it will become first 0 triple F and store H contents, HL register pair. That is here it will copy H. Then again 0 double F E may it will copy 37. Any problem? Okay, increment H. I'm sorry. Wait. No problem. Wait. So increment H means HL will be copied with next number 2738. So here 8 will come. That's all. Okay, no problem. So push H. Then HL is copied. Already HL is push. Stack point is having 1000. It decrement it and write it. Decrement it, write it. Next, call if zero flag is 1. So you observe here, no flag affected, no flag affected, no flag affected. Here, what is the zero flag? 1. Because zero flag is 1, what is this? Call if 0 equal to 1 to 20FF. So it will come here. So add H. Accumulator is copied with A plus H. Accumulator is how much? 2F plus H. What is H? 27. Okay. Now 2F plus 27. What is the answer? What happened here? Any problem? It is 2F. Okay. Wait. Okay now. So 2F is added with 2F. Okay. So 2F and 2F are added. What is the answer you get? F plus F is 30. 30 means it is 14. 14 is E, 5E. Nishita, only for arithmetic operations, zero flag will be affected. Remaining instructions cannot affect zero flag. So during this period, flag not affected. Okay? During this period, your flag is not affected. Then zero flag is equal to 1. Then call if 0 equal to 1. Add H, it is 5E. Return if 0. Now zero flag is 0 because arithmetic instruction. This is arithmetic operation. Zero flag is affected. Is it clear now? You understand the concept. What is the meaning of RZ? Return if 0 is equal to 1. Return to which location? Top two locations of the stack. This program will tell you all. You can recollect everything from this. Pop B. Pop B means now what happens is your stack pointer will be copying this to B 38 and 2F. Yeah, it is written if 0 flag is equal to 1. RZ means return if 0 is equal to 1. But 0 is 0 na. It will not return. Return means what? Program counter is copied with the top two locations. That will not happen here. Okay. See here. Pop B and push B. You can say it is redundant. Okay. But BC will be copied with, please listen, one effect is there. BC will be copied with this number. What is that number? 2F38. Okay. Pop B may BC is copied with this. When I say push B, redundant for what I'm saying is a stack. I'm sorry for not writing much larger. So return if no 0. Yes, 0 flag is equal to 0. Yes, return. Where to return, sir? TC is copied with top two locations of the stack. What are the top two locations of the stack? 2F38. That's all. Now what is the question? If program counter is copied with 2F38. So examiner asked PC value, SP value, B value, C value. I hope you can do it. Just to make that note. HLS. I think SP is what? 0 FFE. PC is equal to 2F After halt instruction is executed. After halt is executed, which halt will be executed? Just wait. Just wait, Rahul. After halt instruction will be executed. Actually, if this is called, it will run. But here there is no 1 minute here. Okay. So see here, these are the instructions. First SP is copied with this, HL is copied, space is less, that is a problem. Accumulator is copied, increment H and push H. HL is copied here. Calls if zero flag is equal to 1, jump to 3000. Actually, it will call because zero flag is already 1. So call to which location? 20FF. 20FF mein what happens? Add H. A is copied with A plus H. Okay. And what is that? Return if zero flag is 1. Okay. Actually, see, I missed one thing. After this push, whenever I say call, it will again push it. We missed that part in the question explanation. You understand or not? Let me write. Is it visible if I write like this? I'll do it again, don't worry. Is it visible? Okay. So let me try to write here itself. SP is copied with 1000. Otherwise, just copy paste. Wait. We have this screenshot facility. Control C not working here. In this. If that is there, it could be easy. Okay. So listen here. So firstly, SP till now in branch group, whatever we discuss, everything is there in this question. SP is 1000. Okay. Push and pop we can say now. Okay, I did push here, pop here. So HL is copied with the number 2F37. A is equal to 0, 0 and 0 flag will be 1. Move A comma H. A is copied with 2F. Increment H. HL is copied with this. Okay. 2F38. Then push H. Now see here. Stack point reset what? 1000. You have SP. This is 1 triple F, 1 double FE, 1 FFD, 1 FFC. Not 1, yeah, 0. O. Okay. Where? A will have H only. H may what is that? First part is the H. Vasista. H, this is H and this is L. Is it okay now? Right. So this is where firstly what I am doing is push operation. During the push operation, I am writing in green color so that it will be different. During this push operation, push HL. HL will be pushed. That is, first stack point is decremented. H is copied, then L is copied. Okay, so the stack pointer is moved to this point now. Then what is that? Call if 0. Yes, 0 flag is equal to 1 only because here. So call to which location? 20FF. But by this time, you need to here do so many things. This is a 3 byte instruction, 3 byte instruction, 1 byte, 1 byte, 1 byte, 1 byte. Total how much? 6 plus 2 plus 8 plus 2, 10. So this location will be 200A. Will you accept it? This is a 3 byte, so it will be 200ABCD. It's a conventional question. Yes, I think. Okay, I think given for 10 marks like that. Not objective question. Okay, so is it clear what I am doing? It's a 3 byte, it's a 3 byte, 1 byte, 1 byte, 1 byte, and 1 byte. So total 10 bytes. Then 200A because it is 0, then 3, then 6, 7, 8, 9. A means 10, then plus 3, 14. 10 plus 3 is 13. 13 means D. So this is so whenever 0 flag is 1, call to 20FF. It will go to this location, but before going that, it will store this value in the stack. It will store this value in the stack. So now what is that value? 2008. 0, what is that? D. 0D. 0D. OD. So stack pointer will move here. Now currently your stack pointer is here. Okay, now computer will come to here, H will be added. So A will be copied with A plus H. So A is how much? What is A? 2F plus 2F. What is that? 5E. 5E. So return if 0 flag is equal to 1, then return what? No, because 0 flag is addition may, what is the 0 flag now? 0, because answer is not 0. Answer is not 0, so 0 flag is modified to non-zero. That is, answer is 0, 0 flag will become 1. Answer non-zero, 0 flag will become 0. Don't confuse. So, but no. So that's why it will not return. Then pop B and push B. This may SP not changed. Please understand. But VC will be copied with top 2 locations. Because we said pop, so it will decrement, it will increment. When again we said push, it will increment. Okay, first we read into BC, again we write in the BC, we write from BC only, so it will not make any difference. But first time it will decrement, so first time it will increment the stack, second time it will decrement the stack. This point is clear or not? Please ask. Someone asked me earlier, Rahul, I think. When I say pop B, BC will be copied with this top 2 locations. Then when I say push B, okay, when I say push B, then what happens? It will again rewrite the same thing. But now BC is containing 2000. Very good. So now the next instruction is return if no 0. Return if 0 flag is 0. Yes, 0 flag is no 0. Okay, please understand. No 0. That is confusion तो नहीं होना चाहिए. Is it clear? इसमें return if 0 flag is 0. 0 flag is 0. Return if no 0. Yes, return. Where to return? Top 2 locations of the stack. Top 2 locations of the stack में, so PC is copied with 2OD and stack pointer will be incremented by 2. For R and Z. During R and Z, stack pointer is incremented by 2. Okay, otherwise I will use another color so that you can understand better. So during this period, 20 0D will be copied. So stack pointer will be in here. Now what happens? It will go to 200T. What you have here? Jump to 3000. Then it will come to here and halt. Okay, jump to 3000 will happen and halt. These are the step by step. First step, second step, third step. Okay. Now examiner को क्या चाहिए? Let's give him whatever he want. He want PC content. It is 3001. That is whenever it is coming. Actually it is 3000 only. Halt may it will not increment by 1. Take it 3000. Okay. Because halt we have not discussed. Tomorrow we discuss it. Then program counter will be, or 1 minute. Yeah. Just take it. Yeah, it will clear everything about whatever we call what is that, all your it will make you good revision of all your branch control group of instruction. PC will be 301. Stack point is how much? 2 times done, na? So OFFE. Stack pointer, not stack contents. Then what is your BC register? BC register is 2 OOD. Why it is writing like this? Next, HL register. HL ko kya? HL is where it is anywhere modified. Increment H 2F38. Very good. It is writing like this. Not listening to me. What happened to it? Don't write like this. I think it is exhausted because we are taking extra time. What is the problem? This is a different instruction. Okay. Yes, lastly, I'm making the answers. Okay. So PC is done. SP is how much? SP is how much? OFFE. Next, BC is 2OD and HL. HL is how much? 2F38. These are the right answers finally. Okay. So, but please listen here. You are able to remember or recollect all the things, yes or no? And also, it makes a good practice. So, what is your doubt beneath? Sir, in push H, SP data will be, SP data will be, see, SP data will be push H. Yeah, it is 2738, man. I'm sorry. Push is after this, na? I'm very sorry for that. Okay. Are you happy now? Program counter is 3001 only because halt may first second T statement don't know it is halt, na, it will increment. After where it will understand fourth T statement will understand. Okay. So end of the day you are very happy. Stack pointer is here, na. It has a simple stack pointer calculation is easy. You have 1000, na. Push decrement 2. Call decrement 2. If it is pop, increment 2. Push increment 2. Return increment 2. Simple logic is. So here how many decrements, increments like that you can. It is your homework question only, Shivam. This is from your homework only actually. So we need to halt for class. You people are waiting for that. Don't worry. I will also halt. So remaining questions yesterday, please listen. Yesterday I have given you 50 questions. Yesterday I have given you 50 questions. This is 20 questions which we have now uploaded earlier, but I have left a few questions because of not discussing this all instructions. Now you will be able to do all questions. Please give a try. Today you make this practice. Okay, today's DPP, and I will upload in the groups also both the DPPs. Okay. Yeah, all the 4 DPPs we can upload. Thank you. Bye bye. Good night. So tomorrow we complete this and we do more number of programs. Bye.